The second type of actions are called differential actions, and I can inspect that in my editor. And if you see, the node looks very much like a standard action, and the only difference for now is the name, but this is just a string that I can change here. I'm going to call it move div. And the difference between these types of actions and the first ones is that this one will invoke its onTick event every time the tree ticks on the node. And the onTick event is the same as before, a public void method which takes a string, an action node, and a game object, which refer to the action node that invokes the event and the game object that ticks on the node again. And now we can see how these types of actions are implemented in the same Koala move actions. And here I have the differential method. The first thing you can see is that I'm not calling a coroutine at any time, and this makes them a little bit simpler. And again, the first thing I do is I parse the values that come from the string. I create a vector and the velocity, and then I transform the position. I add just a tiny bit, which is the velocity times time dot delta time. And again, I feed the node dot action debug info with a string of what I want to show, which in this case is this vector called new delta. Finally, I check if I'm close to my target or not. If I'm close to the target, I return early, and if I'm not, I go to the node.action status again and set the status as running. If I bail out early, I set it as success. But the thing is that if I only tick once, I can test this in the editor. I'm going to choose this one and make sure that you've selected the editor option so you can test it inside the editor. And then if I tick on it, let me move it somewhere else, and let me set the parameters to go to the origin, so 0, 0, 0, and then a speed, which I will set to 2, and then I'm going to reset its status. And again, you have this tick button now, and you can tick only this node in order to debug, but I'm going to tick the whole tree. And now if I tick, you can see that it moves just once, and there's no coroutine running, and it's just one step every time I tick. And when I get to the target position, which is 0, 0, 0, it returns success. So this works in a bit of a different fashion, and how you want to set up your behaviors depends on whether you want to check for the whole tree every time you tick, because this one will return every 2 ticks, it will return the control to the whole tree, and the other one will wait until the coroutine finishes. So that's the main difference between the two of them, and this will also play with the different types of selectors and sequencers that we can use. So in the next video, I will go into the selectors and sequences, and you will see how they play along with the different kinds of actions. But for now, you should be able to implement conditions and actions which are specific to your projects using either coroutines or differential actions. Okay, see you in the next video.